Viewers all over the world. This is another STEM communication. Today we are looking at another of STEM subjects, which is mathematics. And the topic we are looking at today is in three parts. We are going to have three different video production on this particular topic, and it's on Pythagoras theorem. Part 1, Pythagoras theorem. Actually, this topic is meant for students that are in juniors high school 2, GSS 2. And it found application in virtually several aspects of mathematics down to the university. I remember when I was studying civil engineering, and there's a course we need to take on surveying. I remember that while we are trying to calculate the perimeters, the radius of land area that we surveyed, we do make use of Pythagoras theorem. So that means all this topic that you learned right from primary GSS class has areas of application even in higher institution, even in the university. And so I want you to be very attentive as we discuss and communicate Pythagoras theorem. Now, the name Pythagoras, please take note of the name, the spelling. Pythagoras, Pythagoras, is actually the name of a mathematician, a philosopher, a Greek philosopher who have lived for about 2,500 years ago. He came up with this theorem called Pythagoras theorem. And Pythagoras theorem has to do with a particular type of triangle. You remember that there are different types of triangle. We have equilateral triangle, isosceles triangle, scaling triangle, and we have right-angled triangle. But this particular theorem has to do with right-angled triangle. It is only a right-angled triangle that has all its three sides having special names. You are going to get that right here, right now, okay? It's only a right-angled triangle that has special names attached to its three sides. I'm sure you remember and you know very well that a triangle, from the word tri means three, it means it is a three-sided figure or a three-angled figure. So Pythagoras theorem based its theorem on a right angle. Can you see a right angle triangle? How do you identify a right angle triangle? One of its angle must be 90 degrees. Okay? The 90 degree is formed at the perpendicular intersection of a vertical line and an horizontal line. This one is an inclined line. But if you look at this one, it is standing vertically erect, and this one is standing right horizontally. Okay? Where the two meet, there is an angle that is being created called 90 degrees. This is how to symbolize 90 degrees. You can see it like a square. It means 90. Okay, I don't need to put 90 there. Once I see this, I know that this is 90 degrees. So Pythagoras based his theorem simply on a right angle triangle. Do not forget that, right angled triangle. Let me write it here. Right angled triangle. Okay, now, so what does this man say about a right angled triangle? What is his theorem? What is his formula? How does he connect the three sides of a right angle triangle? Before we go into that, let us know the special names given to a right angle triangle. What are the names? What are the names of the sides of a right angle triangle? If you look at this figure here, you will see that this angle is 90. This angle is labeled beta, and this one is theta. Now, the sum angle of a triangle, look here, the sum angle of a triangle, if we add these three angles together, this 90 plus this, it must give us 180 degrees. And since one of them is already 90, it means that this theta and beta must be what? 90 also, because 90 plus 90 give us 180. So this two is already 90. Theta plus beta is 90. So if you put 90 there, 90 plus 90 give us what? 180. You need to get that right. The sum angle of a triangle is 180 degrees. Now, if you look at the three sides, one is standing vertical, one is lying flat, horizontal, then one is bending. Can you see that this one bends? we call it inclined. We said it is inclined. And if you look at it, even by visual observation, this one that is inclined is longer than this one and this. Okay? So this one that is inclined is called hypotenuse. Look at it. Hypotenuse. Hypotenuse. We signify them, we symbolize them by letter H. Then the one that is inclined is hypotenuse. We can also call it the hypotenuse, which is the edge. You can call it the inclined side. Inclined. It is inclined because it is bent. You can call it the slanting side. Slanty side. For example, a cone like this. A cone has a side that is slanty. It also has a vertical height. We will come back to that, okay? So this hypotenuse is called the inclined side, the slanty side. Some people even call it ladder side. Ladder. The ladder side. You know, when you want to climb the roof of the house, you have to place your ladder against the wall and it forms this something like this, an inclined stuff like this, okay? Do you understand? It forms something like this. You can see the ladder and you'll be able to climb. Do you see that? Okay, that's why the hypotenuse side is also called the ladder side. So there are three names you can call hypotenuse. Is the inclined side, is the slanted side, is also the ladder side. Okay? Now, it means that if you look at this hypotenuse, this side is directly opposite the right angle triangle. Look at it. Can you see that? The side that is directly opposite the 90 degree, okay, is the hypotenuse side. Hope that is taken. The side that is directly opposite the 90 degree, this is the 90 degree, this is the side that is directly opposite it. So, okay, and it's the hypotenuse, okay? So, okay, let me put the right nomenclature here. That is the H there, okay? Let me clean this. That is the hypotenuse. It's also the hypotenuse here, okay? It's also the hypotenuse here. Alright, now, so what about the other two sides? The other two sides, they change position. It is only the hypotenuse that is fixed. Others are not fixed. Okay? It is only the hypotenuse that is fixed. Others are not fixed. Do you understand? So the other two sides can either be opposite or what? Adjacent. How do you know if this is opposite or adjacent, or this is opposite or adjacent? It depends on these two angles. Okay? Now, figure 2. Look at this second figure now. I want to pick angle theta. If you reference this angle, if you reference this particular angle, you can see clearly that the side that is opposite it is this. Opposite. O stands for opposite. Do you see that? It is the one that is directly opposite this angle, theta. So this becomes the opposite. Then automatically the third one will not be adjacent. Is that clear? Now let's look at this figure now. I want to reference this angle better. If I reference this angle, which side is opposite this better? You can say this is the angle. Okay? Can you see that? That is the angle. That is the side that is directly opposite this angle better. So this becomes the opposite. So it means that this now becomes the what? Adjacent. So it means that once you identify the opposite side, the third side will be the what? Adjacent side. Very simple. Okay, now let's come back to what we have here now. I want to clean this. I want to clean this. Now, what does Pythagoras theorem says? Let's go back to the theorem. What does Pythagoras theorem says? It says this. This is what it says. It says that if you pick the longest side now is the what? Hypo is the longest side. The hypotenuse is the longest side of any right angle triangle at any given point in time. Is that clear? Is the longest side. If you pick it, which is letter H, you pick it like this, H, and you square it. You square it, raise to the power 2. It must be equal to, according to Pythagoras theorem, the square of the other two sides, that is opposite side, you square it, and the square of the adjacent sides. Okay? Look at that. This Pythagoras theorem. It says that the square of the hypotenuse what? Side equals the sum means plus, the sum of the square of the other two sides. That means you square the opposite and you also square the what? Adjacent. Then what you're having is what? Pythagoras what? Theorem. So it means that your business is to, number one, identify the hypotenuse what? Side. Once you identify the hypotenuse side, it is the only one that will stay at the left hand side. Do you see that? It is at the left hand side. Then the other ones, opposite and adjacent, their square is at the right what? At the right hand what? Side. Do you see that? At the right hand side. Okay, so that is what do you call it? That is Pythagoras theorem. Okay? Now, can we take an example now? Now look at an example on that. Let's take an example on that. Somebody gave you a triangle like this. Look at this triangle. Okay? A right angle triangle. Look at this. Now, this is the hypotenuse. They say the hypotenuse is 10 millimeter. 10 millimeter, can you see that? Then they gave you another side to be 8 millimeter. This side to be 8 millimeter. And they want you to find this place as y, the other side. This is what we are giving. Now, we already know that this is angle 90 degree, right? And the side opposite angle 90 degree give us the what? The hypotenuse. Is that also? So the hypotenuse here is 10 millimeters. Is that also? Then the other two sides, you pick an angle as 90. Take an angle as 90. Take an angle as theta out of the remaining two angles. So that you'll be able to know which one is your opposite. Okay? So since this is hypotenuse, you square it. 10 raised to the power 2. The hypotenuse side will be equal to, now if you pick this angle as theta, this becomes your opposite. So you square the opposite is what? 8 what? 8 squared. Plus the other one will not be the what? Adjacent. Then you square it also. Y squared. Okay? That's y squared. Now, what do you have? You are looking for y. So to find y, what do? To find your y now, you try to open this up. 10 squared means 10 times 10. 10 raised to the power 2 means 10 times 10. That is 100. 100 equals to 8 squared. 8 times 8, 64. That's 64. Okay? Plus, then we have what? Y raised to the power what? 2. Okay? So what are we doing now? You are looking for y. You take this to the other side. Take this 64 to this side. You collect like terms. So I want to clean this. So what we have left is this. You now have 100 okay, minus 64. It is plus 8 not to minus equals to y squared. Okay? Can you see that? Now, what is 100 minus 64? That gives you 36 equals to y squared. Now, to find y, you need to remove this exponent, this cap. And the only way you can do that is to square both, to find the square root of both sides. You find the square root of this, you also find the square root of this. Don't forget, in mathematics, you must always maintain equilibrium, a balance. Whatever action you take at the right hand side, you take it at the left hand. What is the square root of y squared? That is just 1y. What is the square root of 36? That is what? 6. Because 6 times 6 is giving you 36. Okay. Now, let's now look at this other problem here. I want to clean this using Pythagoras theorem. Then I will now explain to you what you do with those ones over there, right? Okay, now, Look at this. You are given this figure. We have to find x and what?
Right.
Y. Are you seeing it? If you look at this figure, you can identify two right angle triangle. If you take a knife, I mean this thing is on the paper, you take a knife and you cut it at this place. You can have two right angle triangle, right? Okay? The two of them shared one in common. So that means you have something like this. One is like this. The other one is like this. Let me bring it down. One is like this. The other one is like this. The same length here. Like this. And like this. Can you see that? If you take a knife, this is right angle triangle. This is right angle triangle. This place, the boundary length between this triangle and this triangle is y. This is also y here, okay? Now, this is x here. This is 6. This is 26. And this is 24. So, in applying Pythagoras what? Theorem here. In applying Pythagoras theorem, what do? You try to apply, you try to start from, study the information given. If you look at this bigger right angle triangle has two information. This one has one information, two unknown. In mathematics, you start from known to what? Unknown. You start from where there is enough information to where there is less information. Now, so that means start from this one. Okay? So, if you look at this, the side opposite angle 90 is 20 what? 6. That is the hypotenuse. So, you have 26 squared. This marker is. Marker is not marker. Okay, thank you for that. So, we have 26 squared equals to the other two sides. One is either opposite or adjacent. So, y squared plus 24 squared. Okay? So what is 26 times 26? You multiply it out here and you try to get that. That's 36. That's 36 times 6, 12. That's 15. That's 12. That is 5. So that is 6, 7, 6. Okay? Equals to y squared plus what is 24 squared? 24 squared is 24 times 24. Let's see that. 4 times 4 is 16. 2 times 4, 8 plus 1, 9. 2 times 4, 8. 2 times 2, 4. Okay, that is 6, 7, 5. That is 5, 7, 6. Okay? Now, so from this we are looking for y. I need to carry this to the other side. So that will be 6, 7, 6 minus 5, 7, 6, right? Equals to y squared. Okay? If I clean this now, what do I have? I have this minus this. It is obvious that it is 100 equals to y squared. Okay? If you find the square root of both sides, we have square root of this and square root of this. Square root of 100 will give you what? 10. And square root of y squared will give you what? 1. Okay? So now it remains our x now. So we have gotten our y. So we can now get our x from this. Okay? From the other part of the figure. The other component. Look at that. We have known our y now. So we can find our what? X. Again, if you consider this triangle, the side that is opposite this right angle is y again. Is that not so? So this y becomes what? Hypotenuse. So you now write again now that y squared equals to what? X squared plus 6 squared. Okay? This one is 10, so you put 10 here. 10 squared give us x squared plus 36. Okay, let me just put it there, this first. Equals to 6 squared. Okay? Now, 10 squared means 10 times 10, that is 100. Equals to x squared plus 6 times 6 is 30 what? 36. So take this to the other side. We have 100 minus 36 give us x squared. 100 minus 36 give us 64 equals to x squared. So to find x now, you find the square root of both sides, okay? So the square root of 64 is 8. The square root of x squared is just 1x. So we have known our value of x and y to be 10, to be 8 and 10 respectively. That is application of Pythagoras what? Theorem. So we have some exercises here for you to do. I will encourage you to practice these 3 exercises. If you look at this figure here, all you need to do here is that you can identify how many right angle triangle here? 2. So it means if you slice it here, if you cut it here, you have 1 and you have 1. This P is common to the 2. Then you start from where there is sufficient information to the where there is lesser information. Okay? Figure 2, look at this. How many right angle triangle can you see here? 2. If that means if you cut it here, like this, there is one right angle triangle, another right angle triangle. Then you can now go ahead to find your M and your what? N. Number 3, now this one is a bit different. There is a right angle, there is a small right angle triangle inside a big right angle triangle. Can you see this small right angle triangle? This small one, is that also? You bring it out. Then there is a bigger one. You bring it out also. Now, the small right angle triangle and the big one, they share this side in common. Is that also? The two of them have the same K. Is that also? So with that, go ahead to find your K and what? D. If you are fully registered with this particular platform, as you have widely publicized, then you attempt this. Once you are fully registered, attempt this and send it to my WhatsApp page. I will look at it, look at what you have done, and give you a feedback. So with this, we have come to the end of Pythagoras Theorem part 1. With there is still part 2 and there is still part 3. Keep subscribing to this particular channel, share with your friends and neighbors, and try to support this particular channel. Till next time we meet on part 2 of this very topic, keep fit.
Touch my wicked point, oh. Make them throw me punch, say me I go take it out, oh. If them make them talk, oh. Make them talk rumors, oh. Make them throw me punch, say me I go take it out, oh. Baby make you no do cow, oh. You take anything where you want, I be talk and do. Money too long, it get part 2. I know say you dey feel me, so no good, they mess a boo. Girl, you dey reason me one kind, any day pay me, oh. Any day pay me. If na cash where you want, I go way below. Girl, if you ever for my hand, that thing go change me. Oh, say it go change me. If I go ever love you, now baby, oh, if I ever hurt you, girl, I'm sorry. Oh, my baby, no go leave me for lose, I did.